All right, welcome back to third lesson in Unit 8. We are looking at trig functions today, and we're going to be looking at the graphs. Okay, so trig functions. So we're going to be looking at three different ones: sine, cosine, and tangent. We are actually not going to be looking at the reciprocal function, reciprocal trig functions. We are just going to be looking at the basic ones: sine, cosine, and tangent. Okay. Now, before we do that, we're going to look at this example here. This warm-up question. It says, this graph shows how the number of hours of daylight in equilibrium varies throughout the year. Okay, so here's the graph to show the hours of daylight per day. Okay, and here are three questions. First, it says approximately how many hours of daylight are there on the longest day of the year. So if you look at this graph, y-axis being the number of hours of daylight, so the longest day of the year will be approximately here. And this looks like about, I don't know, 20 hours-ish. Okay, about 20 hours. We are just going to do some approximations. We are not actually going to be exact. That's okay. That's not the purpose of this activity. Approximately how many hours of daylight are there on the shortest day of the year? So that'll be here. This looks like approximately maybe 4 hours. Okay, and then finally the question asks, why is it reasonable to expect that this pattern to continue or to repeat annually? Well, because the number of hours of daylight shouldn't change all that much from year to year. It should repeat, right, itself over and over, year after year. So it is definitely reasonable to expect this pattern to continue throughout the next, 10 years, 20 years, or even longer, right? Okay, so we can actually expect this pattern to continue, and anytime we have a graph where the pattern continues or repeats, we call this, okay, we're going to skip this middle part first. A function that repeats itself in a regular interval over its domain is what we call a periodic function. Okay, periodic function. So again, it repeats itself over and over again within certain interval, right? So in our graph here, the interval would be a year, right? Every year it's going to be a little bit, it's going to be the same, right? Every year it's going to be the same. Okay. All right. Just keep falling down. Anyways, the length of each interval or cycle measured along the horizontal axis. This is what we call the period of the function. Okay. So again, the length of which that it repeats is going to be, or it takes to repeat, right? So you can see in this graph, the period is going to be 1 year because that's how long it takes for one cycle to finish or for one period to finish. And we call that the length of the time, or the length of the graph is what we call the period, okay? So again, the length of each interval or cycle is what we call the period. And again, we are going to be looking at three trig functions today: y equal to sine x, cosine x, and tangent x, and we're going to look at their properties. So y equal to sine x is the value of the sine ratio for an angle measuring x radians. Same thing for cosine, it's the cosine ratio, and tangent is the tangent ratio. Now, if you recall from, I think it was the first lesson, sine ratio, okay, this is about y value. Okay, we think about y value when we talk about sine. For cosine, remember this is about x value. And when we think about tangent, this is y over x, okay? So we're going to use this fact to graph our sine function right here. Now, of course, the graph here is given to you. Here it says, the sine function y equal to sine x is a periodic function with period 2 pi. Okay, this really has something to do with our unit circle. Okay, recall unit circle has, one full rotation is 360 degrees, or in terms of radians is 2 pi. So that's why the period is 2 pi, because if you go around once, you're just going to repeat that circle, right? You're just going to continue with that rotation. And that's why the period is 2 pi. Okay, now the domain for this sine function is all real numbers because you can just keep rotating forever. Okay. Now, before we answer these questions, I guess I answered the first one already, but I want to show you how we can get this graph. Okay. So again, we are looking at a sine function. Okay, so sine, we think about y. So again, anytime you see sine functions, I know it says sine x, But when you see sine function, you think about y values on the unit circle. Okay, so we are going to start from here, right? That's where we always start, the positive x-axis. What is the what is the y value when angle is 0 radians, right? Because this is 0 radians, and this right here is pi over 2. This is pi, 3 pi over 2, and back to 2 pi, so 0 and 2 pi. Okay, so at 0 radians, you can see the y value is 0, right? So you can see the y value is 0, so that means we are going to be at 0. Okay, so it's kind of tricky. It's the y value on the unit circle. Well, I guess it's still y value here. Okay, so that's not that bad. It's the cosine that's kind of interesting or confusing. So now if you look at this point, this is when the angle is at pi over 2. And the y value at pi over 2 is 1. And therefore, at pi over 2, that's right here, the graph, you can see the y value is at 1. Okay, if we keep going, and you can see between 0 and 1, here is the y value, right? It's getting bigger and bigger, but it kind of slows down. Just like this, it gets bigger and bigger, but at the end, the y value slows down, right? The way that it increases, the rate in which it increases slows down. Okay, now from pi over 2 to pi, so from pi over 2 to pi, you can see the y value goes from 1 back to 0. You can see goes from 1 back to 0 at pi. And you can see the graph or the y values is decreasing. It started slowly and then it decreases quite rapidly at the end. You can see it decreases slowly and then goes down more quicker as you go towards pi. From pi to 3 pi over 2, that's here. 3 pi over 2 is right here. You can see the y value goes from 0 to -1. You can see it goes from 0 right here to -1 for your y values right there. And then finally, it goes back to 0 at 2 pi, right? The y value goes from -1 to 0. And you can see here are your 5 points. And there is your sine graph. You can see there's your sine graph. And this direction, I mean, you're just rotating clockwise instead. Okay, and you can see negative pi over 2 is right here, which is -1 for the y value. Negative pi is right here, and you can see the y value is 0. Negative 3 pi over 2 is right here at pi over 2, and the y value you can see is 1. If you go back to negative 2 pi, that's 1 full rotation, and you can see you go back to 0. And so there is your sine graph. Okay, hopefully you understand how we get this graph just basically from this unit circle right here. Okay, so the zeros, recall the zeros are the x-intercepts. So you can see if we can just write down a few zeros, the zeros in this window is negative 2 pi, negative pi, 0, pi, and 2 pi. Therefore, we can actually write this in a general form. This is going to be pi times n, where n is the element of integers, right? So n could be 0, 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5, and so on. So zeros would have the form pi n. For this sine graph, you can see it has a maximum value of 1 because, again, in the unit circle, the biggest y value is 1, and the smallest y value is -1. So the range goes from -1 to +1. Okay. Now this is obviously just a simple sine function without any transformation, right? You probably see this coming. We are going to be looking at transformations next lesson. But this is the basic sine function. You need to know what it looks like and how to graph it, because we are going to start from here and then we're going to transform from here. Okay, so you must know the basic function first. You need to know what it looks like. Okay, basically it starts with 0 and with a 0, right? So I'm talking about one period. Start with a 0, ends with 0. In the middle is a 0. Between the first two zeros, you have a maximum. Between the second and third 0, you have a minimum. Okay, so that's what a sine graph looks like. Begin with a 0, end with a 0. Middle is a 0. Between first two zeros, max. Between second and third 0, minimum. All right, so that's the sine function. We're going to move on, and we're going to be looking at the cosine function. Okay, so the cosine function y equal to cos x. Remember, when we see cosine x, we think x values, okay, on the unit circle. It's a periodic function with period 2 pi. Again, it's 2 pi because, again, one full rotation. All right, so we start at 0 radians. You can see the x value is 1. So you can see at 0, the y value is 1. So this is where it's kind of tricky. I know on the unit circle, we're looking at the x value, but when we draw it, okay, this is y equal to cosine x. Okay, so the y value is what cosine is. So cosine is the x value on the unit circle, but that actually turns out to be the y value on the graph. Okay, so that's, okay, be careful because we're looking at the cosine x. So we think about the x value on the unit circle. However, that x value really is the y value on the graph. Okay, so be careful. At pi over 2, the x value, so because we're looking at cosine, x value is 0. So you can see at pi over 2, the y value here is 0, right? We're at 0. At pi, the x value here is -1. So at pi, our y value here is -1. At 3 pi over 2, our x value is 0. So at 3 pi over 2, our y value is 0 on the graph. Finally, at the end, once we return to original position, so that's 2 pi, that's 1 period, the x value on the unit circle is 1. So you can see when it goes back to 2 pi, here is 1 for the y value on the cosine graph. Again, same thing if you go backwards, okay? So I'm just going to plot the points. I will not explain again because you're simply rotating clockwise instead, right? So every pi over 2, you go to this point, that point, that point, that point. But you're looking at the x value this time because we're looking at the cosine function. Okay, so cosine function has a domain of all real numbers again because it just keeps rotating, and I mean, you could go on forever, right? There's no stoppage. The zeros in this case is, or are, this was -3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. So we can rewrite this, or we can write this as pi over 2 plus pi n, where n again is the element of integers. Right? N could be 0, so it's pi over 2. Yeah, that's fine. That's perfect. Okay, so that's the zeros for the cosine function. You can see the function, this cosine function still has a maximum of 1, though it's a different place. And the minimum is still -1, so the range remains the same. It goes from -1 to +1. Did I include equal sign there? Yes, I did. Okay, perfect. Okay, so again, we will do the transformation next time. So make sure you know what it looks like. Okay, so unlike sine graph where it starts at 0, cosine graph starts at the maximum. Okay, starts at maximum, ends with a maximum. Halfway is a minimum. Between between the maximum and minimum, you have 2 zeros. Right. So again, for sine, start at 0, end with a 0, middle is a 0. Between the first 2 zeros, maximum. Between second and third 0, you have a minimum. Okay. For the cosine, you start with the max, ends with a max. In the middle, in between, is a minimum. Between max and min, you have zeros and 0. Okay, so that's how you do cosine graph. Make sure you remember those shapes. Okay, it's important for next lesson. All right, so in general, functions whose graph have the same shape as y equal to sine x or cosine x, they are called periodic functions, but if they look like sine functions or cosine function, they have a special name. They're what we call the sinusoidal function. Okay, sinusoidal function because they look like sine graph. Okay, so these are what we call sinusoidal functions. Okay, a sinusoidal function has a maximum value and a minimum value that are equal distance from the center line. Okay, you can see here the center line is simply the x-axis. Okay, that's the center line, right? Same thing going back here. This is the center line. Okay, hopefully you see that the sine graph and the cosine graph are basically the same graph, except it's just being moved a little bit. Okay, so it's just being moved a little bit. So it's just being shifted. But they are basically the same graph. Okay, so again, there's a center line that is right in the middle of the graph, okay, which is a horizontal line that is halfway between the maximum point and the minimum points. Okay, so halfway between max and minimum, you have your center line right there. Okay, and the amplitude of a sinusoidal function is the distance of a maximum or minimum point from the center line. So you can see from this graph, here it says amplitude right there. Amplitude is simply the distance from either the maximum or minimum to the center line. You can see here the distance is 1. This also has a distance of 1, okay? So amplitude is simply the vertical distance, or the distance from the maximum to the center line, or center line to the minimum. So it's the halfway point. It's the halfway point. Okay. Now here it says, how can you use the position of the center line and amplitude to determine the maximum and minimum values of the sinusoidal function and its range? So I think it might be better if we can figure out amplitude and center line. Okay. Now you can think about the center line is basically the middle. And if you think about middle, right, middle is found by finding the average. So average is simply the biggest okay, sorry there. Again, the center line, the middle, is simply the average, which means it's maximum plus minimum divided by 2, right? It's the biggest plus the smallest divided by 2. You're looking for the average of two numbers, and those two numbers are the maximum and minimum, right? That's how you get a center, max plus min divided by 2. And amplitude then simply is going to be the maximum minus the center line. Or you can actually do it in this way too. There's a formula. It's max minus min divided by 2. I usually don't use this formula because it's less obvious why it's max minus min divided by 2. I always just take the maximum, take away the center line, because it's simply the distance between the maximum and the center line. So I always find the center line first, and then I can find the amplitude, okay, given that we have the maximum and the minimum. Now, we could also be given the center line and amplitude to find the maximum and minimum, right? Maximum then would simply be, well, basically, you're manipulating this formula. We can find the maximum by taking the amplitude, or sorry, I should say, we can take the center line plus the amplitude. And therefore, minimum would be we can take the center line and minus the amplitude. Because simply amplitude is simply the distance, right? So take the center line plus amplitude, so you move up, therefore you get to the max, or you can take the center line, take away the amplitude, so you go down to the minimum. Okay, so that's how you can find max and min, or amplitude and center line. All right, let's do some practice here. Part A says determine the amplitude of the graph of each function. Okay, so recall, if you go back to the graph here, the cosine graph is right here, and you can see the amplitude is 1. Same thing with the sine graph, the amplitude is 1, the amplitude is 1. Now, you can look at this, because there's a value of a here, and remember a tells us there's a vertical stretch, right, by a factor of 2. If the amplitude was 1, and now we are doubling it in terms of the vertical size, I suppose, the amplitude is also going to double, right? So now amplitude is going to be 2. Okay, again, because it was 1, because it's being vertically stretched by a factor of 2, expanded by a factor of 2, therefore amplitude is going to be doubled. Now, for the second one here, amplitude is now going to be 1/3. Negative sign does not matter. Negative sign simply flips the graph, but the amplitude is simply the distance, right? So it does not matter. It does not matter if it's flipped or not. Amplitude is now going to be 1/3 of what it was before. Okay, so amplitude is simply 1/3. Okay, so you can try these two and tell me what they are. Okay, hopefully you get amplitude being 4 here. Again, negative sign does not matter. And amplitude here would be 2/3. Okay, this is true for both sine and cosine. Okay, and of course, we're going to move on to tangent, which you can see the graph is quite different from sine and cosine functions. Okay, so tangent function is a periodic function with period pi in this case. So notice how sine function has period of 2 pi, or that's cosine function, and sine function has period of 2 pi as well. Okay, but for tangent is only pi, and the reason why is because for y, because tangent is y over x. So you can see from here to here, it's 0 to 1, and then 1 to 0. So you can see it's 0 to -1, -1 to 0. So it's really the same thing, right? 0 to 1, 1 to 0. So everything positive, everything negative, if you divide them, it's still positive. but you can see it's for the y values is going from 0 to 1. For the y value, it's going from 0 to negative 1. Okay, so it's always going from 0 to 1, whether it's positive or negative. But again, negative in this case does not matter because everything is positive here and everything is negative there. So negative divided by negative will be positive. And that's why quadrant 1 and quadrant 3 would actually be the same for tangent. And so 0 to 1, 1 to 0 for the x. You can see for the x goes from 1 to 0 as well. I know it's from negative 1, but again, if we don't think about negative sign, it doesn't matter. Quadrant 2 and 4 will be the same for tangent because it's for the y value goes from 1 to 0. For the x goes from 0 to negative 1. Whereas this, it just kind of go the other way, right? For the x value goes from 0 to 1, but y value now it starts from negative 1 and goes to 0. So tangent is negative here, and it's also negative there. But you can see if you don't look at the negative sign, x goes from 0 to 1, y goes from 1 to 0. Same thing over here, 0 to 1 for x and 1 to 0 for y. And since both are negative for tangent, so they are actually the same. So 1 is the same as 3, 2 is the same as 4, therefore 1 to 2 is the same thing as 3 to 4. And that's why the period is just pi. Okay, hopefully, I could also just tell you that the period is pi. Just remember that. Anyways, so the graph, it does have asymptotes here. Okay, so you can see, and it makes sense because remember, tangent, we think about y over x. So we would have an asymptote when x is 0. And you can see x is 0 when it's pi over 2 and 3 pi over 2. So we can, if in this graph, you can see we have one here, vertical asymptote right here, here, and here. And they are negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. So the domain is x cannot equal to pi over 2 plus pi n. And again, n is the element of integers, but it could be anything else. Okay, the zeros is when y equal to 0. So really think about sine graph, because whenever sine is 0, tangent is going to be 0 because you're looking at 0 divided by something. Anyways, if you look at this graph, it's at negative 2 pi, negative pi, 0, pi, and 2 pi, here and here. So it has the form of pi n, and n is the element of integers. Now you can see this graph does not have a maximum and minimum because this graph actually keeps going on forever and keeps going down forever. Okay, like that. Going down, going up, going down, and so on. Okay, it just keeps on going forever. Okay, so there's no maximum or minimum, and therefore there's no amplitude, because amplitude is the distance between center line and maximum, but we don't have one. The range in this case is all real numbers because it keeps on going forever to up and down. Okay, so that's the tangent graph. It's quite different from sine and cosine. Okay, example 2 is as determining a period for tangent functions. So the period, remember, if we have this function sine of bx, recall the factor, it was x over b. And in this case, because the period for sine and cosine, it was 2 pi, and if we are stretching it, expanding or compressing it by the factor of 1 over b, then it's going to be 2 pi times 1 over b, and that's why it's 2 pi over b. Again, this is the expansion or compression factor. So if you multiply that by the original period of 2 pi, then it becomes 2 pi over b. Similarly for tangent, because the period for tangent was just pi, so it's just pi over b instead of 2 pi over b. Okay, so just be careful. For sine and cosine, it's 2 pi over b, but for tangent is pi over b. So in this case, sine of 2x is going to be the period is going to be 2 pi divided by 2, which is pi, compressed by 1/2. In this case, it's going to be 2 pi divided by 3 out of 4, which is going to be 8 pi over 3. That's the period. Finally, for tangent, so just be careful, it's pi over 1 over 6. So in this case, the period is actually 6 pi. Okay, so be careful, it's 1 out of 6 here, not just 6, right? Because this is 1 over 6 times x. Okay, so I'll let you try the next 3, and I'll show you the answer in a bit. All right, so hopefully that's what you got. Okay, so make sure it's 2 pi over b for sine and cosine, pi over b for tangent. Okay, we're gonna move on to phase shift, which is the horizontal shift. Okay, movement. So here it says consider the functions y equal to sine x and y equal to sine of x minus pi over 3. You can see here's the value of c right there, right? In the transformation unit, that was the value of c. So we are actually moving pi over 3 to the right. You can see the second graph here, this is the y equals sine of x minus pi over 3. It's being shifted from here to here. So you can see the shift, the horizontal shift is pi over 3, horizontal translation. So the graph of y equal to sine of x minus pi over 3 is congruent, meaning they are exactly the same as the graph of y equal to sine x. But it has been translated pi over 3 units right. In general, the graph of y equal to sine of x minus c is the image after the graph of y equal to sine x has been translated c units horizontally. This distance is what we call the phase shift, okay? There's a special name for it, okay? So this is what we call the phase shift. Okay, so far we learned 3 different words. Period, what else? Period, vertical, the amplitude, there you go, sorry, amplitude. Amplitude is for A. B is telling us the period, okay, and we see the phase shift, and the vertical translation is what we call the vertical displacement, and we're going to see that in a bit, okay, not quite yet, okay, but horizontal shift is what we call the phase shift. Okay, so let's look at the third example here. It says determine the phase shift of the function y equal to sine of x plus pi over 2. So there's a phase shift, pi over 2 to the left, right? Because it's x plus pi over 2, so it's actually to the left, not to the right. Okay, that's an F, not a T. There we go, left. So we want to sketch, oh my goodness, that's a typo right here. We don't want to sketch the graph of tangent x, we want to sketch the graph of sine x and sine of x plus 2. Sorry, sine of x plus pi over 2 for 0 to 2 pi. Okay, so from 0 to 2 pi, I'm going to say we're going to start from here. Here's my halfway. I will make 4 boxes as pi over 2. So pi over 2, 1, 2, 3, 4. Pi, 1, 2, 3, 4. 3 pi over 2, 4. That's 2 pi right here. 3 pi over 2, pi over 2. Okay, so first I'm going to draw the sine function. Okay, so recall sine function starts with a 0. The period is 2 pi for sine function, so it starts with 0, ends with a 0, halfway is a 0, halfway between the first 2 zeros is a maximum. In this case, the maximum is going to be 1. So I will say that 4 boxes is 1 here. So I get the graph nice and space out. So here's -1. So between the first 2 zeros, you have a maximum. Between the second and third zero, you have a minimum. So here is the sine graph right here. Between 0 and 2 pi, looks something like that. Okay, now I will use a different color, let's say red, for this graph right here. So we are moving pi over 2 to the left. That means 1, 2, 3, 4. Here is my negative pi over 2. Okay, so that's my graph, or that's my new starting point, I would say. So I'm going to start right here because I'm moving it to the left by pi over 2. Now I know the period is 2 pi, so from negative pi over 2, that goes from, that's pi over 2, pi, 3 pi over 2, 2 pi. So it's going to end right there. And halfway between the starting point and end point, in the middle, that's right here, is a 0. Between the first 2 zeros, you should have a maximum. Between the second and third zero, you should have a minimum. So there's the sine graph. Again, we don't need to draw this portion because that's not part of the domain. So I'm just, well, I'll show you with a sketch or a dash. And it's really this portion. Okay, and of course, this is going to continue. So you can see the next piece is going to go from 0 to maximum. So here's the maximum right here at 2 pi because that's, there you go, because it goes to the 0 or 1 every pi over 2, right? All right, so there is my sine of x plus pi over 2 between 0 and 2 pi, okay? Minus the dash part, of course. Okay, last example, and here it says describe how the graph or identify transformation of the graph of a sinusoidal function. Again, today we're just going to deal with them separately. We're going to deal all of them together next time. Okay, that's when it becomes a little bit more complicated. Describe how the graph of each function below relates to the y equal to cosine x graph, and then sketch the graphs of cosine x and each function below. I will let's talk about what they are first, right? So here, the difference is that we have a value of a here. So really the difference between this and that is that the amplitude is now 2. Okay, so that means, again, vertical expansion by a factor of 2. Okay, so the maximum is now going to be at 2, and minimum is now going to be at -2. Okay, so that's the difference. Okay, the center line is still at 0 because the one that moves center line would be the value of d, right? That's the vertical, what we call the vertical displacement. Okay, so this is what we, sorry, I jumped the gun there. So this is what we call the vertical displacement. Okay, because we are moving the center line up or down by, in this case, move down by 2. Okay, so this means we're move the graph down by 2. So the center line equation of the center line is now gonna be y equals -2. Okay, so that's where the center line is now. Okay, part B, cosine of 2x. This is changing the period, right? Because that's the value of b. Well, that's horizontal expansion or compression. So now the period is no longer 2 pi. It's going to be 2 pi over 2. So it's just going to be pi. All right. So what we should do first, and I'll let you do that, and I'll show you how to graph these three together. But I want you to sketch the cosine function. Okay. Maybe I'll do that in black. Okay. You know what? I'll do it too. That's fine. I'll do the first one, and then I'll just copy down for the next two. Okay. So cosine function. Let's say move up by 2. Okay. So I'm gonna say my cosine function is, here's 1, 2, 3. -1, -2, -3. And again, I'm going to use 1, 2, 3, 4. Here's my pi over 2. 1, 2, 3, 4. Pi. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. Okay, cosine graph starts from maximum, which is at 1. Remember, just cosine function. And ends with the maximum. Halfway between, it's a minimum. Between the max and min, you have 2 x-intercepts. So there is your cosine graph. Okay, so go ahead, finish the other 2 cosine graphs, and then we'll do these together, okay? All right, hopefully you got your cosine graphs done. Okay, so again, the first one, the only difference is that the amplitude is now 2, which means we are going to stretch it vertically. So the maximum is no longer at 1, it's going to be at 2. 0, because if you multiply 0 by 2, it's still 0, so that doesn't change. Now the minimum, instead of -1, it's now going to be -2, because again, it's been doubled. So that's the same at 0. Again, that's the maximum. It's now at 2. Okay, so you can see here is now the new graph. But you can see the shape or the way it goes is still the same, right? You start with the maximum, ends with the maximum, middle is a minimum. Between the max and minimum, you have an x-intercept. Between max and minimum, you have x-intercept. Same thing, it's just different y values. Okay. Okay, second one right here. Now, our period is now at pi, okay? But nothing else changes. So this is slightly trickier, okay? But again, same thing. You always start with the maximum. In this case, the maximum remains the same because that didn't change. Now, at the end, it's going to be at the maximum again. Now, at the end, it's no longer at 2 pi, right? Because the period is no longer 2 pi, the period is now pi. So at the end means when x is at pi. So here's the starting point. Now, this is where it ends, because that's 1 full period, and 1 full period is pi. Halfway between the maximums, okay, or these maxima, is the minimum. So the halfway in between 0 and pi is pi over 2, and the minimum is now at pi over, at -1 right there, at pi over 2 for the x value. And again, halfway between the maximum and min, you should have a 0. So here is the minimum, here's the middle between max and min, so that's a 0. Middle between max and minimum, so that's a 0. And there is your cosine graph. But that only goes from 0 to pi. We want to graph from 0 to 2 pi, so you just repeat, right? Because it's periodic or sinusoidal. So again, maximum ends with maximum. Halfway you have a minimum. Halfway between max and min you have a 0. Halfway between max and min you have a 0. And there's your cosine graph. Okay. So I think after this you'll know cosine graph quite well, but you need to practice the sine graph. Anyways, the last one here, we have a new x-axis, okay, because we have vertical displacement. It was here, this was your center line. It's no longer there. Our new x-axis is going to be here, right? This is our center line now. Okay, this is our center line now. Now, it says we are gonna, so we move the entire graph down by 2. Therefore, I mean, if this is our new center line, again, we are going to start with the maximum. But the maximum, since we move the center line down by 2, the maximum is now just going to be 1 above the center line. And that's why it's here. I mean, also it makes sense. That's 1. 1 minus 2 is negative 1. So that's my new maximum. But if you just think about the relative location, right? The amplitude is still 1. And therefore, the maximum is 1 above your center line. So start with the maximum, ends with a maximum. Halfway in between, that's right here, is our minimum, which is 1 below the center line. Okay, and between the max and minimum, you should have your x-intercept because we moved the center line down by 2. So this is my new x-intercept, and here is my new x-intercept between, again, the maximum and the minimum. So there is your new cosine graph. Okay. So notice how I just graphed by its relative location. Okay, and that's it. That's all you have to do. But again, next time we're going to combine all 4 transformations together. So that might be a little bit confusing. We'll see how that goes, okay? Anyways, but the key is you need to know sine and cosine graphs really, really well. The basic cosine, like this graph, because we're going to do everything based on that. And you need to know your sine graph, which is the green one right here. Okay, know those 2 graphs very well, and then we'll go from there, okay? That's it. Do some practice questions and let me know if you need some help. Okay, good luck. See ya. Oh, if you're curious why, well, you might know why. Anyways, bye.